Is the screen visible to all of you?
Yes, sir.
Yes, sir.
Very good. Very good.
Good morning, sir.
Good morning. Good morning. Now, let us start. Others also will join in due course. Now, in the previous class, we discussed about the important aspects related to frequency distributions. In the previous class regarding the frequency distribution, explained you about univariate frequency distribution, bivariate frequency distribution. Next, you have the exclusive method, inclusive method, I explained. So today we are going to take the basic concepts and the frequency distribution is going to be explained. So this topic is the last topic in this fourth unit, and the chapter is fourth chapter. And the fourth chapter, last chapter, and the last component that I'm going to explain to you in the chapter. Now, let us see about the information related to this frequency distribution basic concepts. So when you talk about concepts, basic concepts, first variable, you have to understand these basic concepts clearly. Then only you can understand, you can do better the problems. Without understanding these concepts, in the next chapters, problems you are going to solve. Unless you understand these basic concepts, you may feel difficulty in solving the problems and all that. And this component is the last component under this fourth chapter. So basic concepts, variable, first one is variable. A measurable quantity varies from one individual to another individual. Variable is a measurable quantity which varies from one individual to another individual. For example, if a frequency distribution is given to you, a table is given to you, or frequency distribution is given to you, the variable will not be same, or the quantity of the variable will not be same from one individual to another individual. It varies. For example, you can understand better if I explain you about the example. Weights of individuals, if you take, one individual weight will not be the same for another individual weight. So that means it varies from person to person, it varies. The weights will be vary. One person will be 40 kgs, another person will be 50 kgs, 60 kgs, 70 kgs, like that. The weights will be vary from person to person. And you have the age also. Different age groups will be there. It is also unique from person to person. When age is gone attaining, then as per the age, he attains different he enter into different stages and all that. And another example you can take, that is marks. For example, in a classroom, if you take, if you take 40 students are there, say for example, all 40 students will not get the same marks. Some students may get maximum marks, some students may get less than that, For example, if the maximum marks are 100, 100 out of 100 few students may get 90 marks, some students may get 80 marks, some students may get 50, 40, some students may fail 20 marks, 35 marks, or less than that they get. So that means what you can understand, it varies from one person to another person. So but it is a quantifiable, it is a measurable. Each person, each student marks can be measured, and we can identify each student how many marks he got. With that, we can identify the student for improving their performance in the coming examinations, in their future examinations. So that's about the variable. Individual series. Next point is individual series or raw data. A group of single values are raw data. Individual series means, as I mentioned in the previous classes also, only items will be given, only variables will be given, only one column of variables will be given, or the set of the data will be given, raw data will be given. So once you get the raw data, as I told you, as I mentioned in the previous classes, you need to classify it, you need to segregate into groups. Like there's so many things you can do it. But getting data is very important. That is, once you get the data, that is raw data, we call it as. So that raw data can be further classified and subgroups like that, we can do it for better understanding. Under that, you can also understand, if I tell the example, marks obtained by five students marks data. This is, I have mentioned here, 52, 75, 60, 82, 45. These are the marks obtained by the five students. So this is what we call data. So whenever the data has given like this data has to be arranged in a ascending order, so that you can understand better. Better in the sense, who got less marks, who got more marks. So that will be the advantage, or you can understand better when you arrange the data in an ascending order. So that is why, as of now, here on the screen, what you are observing the data, it is only a raw data, which is not arranged in order. What you have to do is, you are supposed to arrange it in order. Say, for example, ascending in the sense, what I told you, ascending order. The least one, you have to identify the least one and the highest one number. The least one among five, what is the least one? 45. And the highest one is 82. So you need to record the least one, 45, as beginning, and followed by 52, 60, 75, and the maximum is 82. Like that, you need to arrange the data under individual series. What I told you, in the individual series, frequencies will not be given. So frequency distribution starts from discrete series. That already I mentioned in the previous class. Now, let us move on to another slide. Another slide talks about the frequency distribution to the in continuation to the 1 minute. Yeah, in continuation to the previous slide, discrete series. Next component is next basic concept is discrete variable. What does it mean? If a variable assumes only integral values at fixed intervals. That means the variable is under discrete series, the variable is fixed. It cannot be changed. For example, say for example here, runs scored by a cricketer. If a cricketer scored 50 runs, so 50 runs are his own. It is fixed to that particular game, for that particular game. Similarly, you have page number of a book. Page number of a book, for example, 500-page book is there. 10th page is unique. The 10th will not be repeated in other pages or previous pages. 10th is 10th. 10th page is 10th page. Like that. And you have the other example also, size of families. Size of family is also unique from one family to another family. Some families may be bigger families, some families will be or smaller families. Like that, it happens. So that is why what you have to understand is the discrete variable. Discrete variable can be assumed as integral values at fixed intervals. That you have to keep it in mind. Next, you have continuous variable. What do you mean by continuous variable? If a variable assume any value between two specified limits, I told you in the previous class, in the continuous series, we will have classes. Classes means lower limit, a class consisting of lower limit and upper limit. That is about the class. A variable assume any value between two specified limits. In the sense example, you can understand height of individual, wage of a person. It varies from time to time. Or you can take 0 to 10 marks if you take the continuous variable series. 0 to 10 are the marks is one group. How many marks, how many students pertaining to that particular group? That means 0 will come up to 9. Exclusive class when you talk about up to 9, whoever gets marks from 0 to 9 will be recorded under that group. That's about the exclusive. Inclusive means what I mentioned, what I told you in the previous class, 0 to 9, say for example, 10 to 19, like that it will be there. In that case, what happens? 0 will be included in that class, in that group, and a 9 also will be taken. And in between, anyhow, will be taken. 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 9 will be taken and will be recorded in that particular group. That happens. Now here, heights of individuals, wage of a person also can be taken as an example under this. Next, you have frequency table. The frequency table, I already explained many times in the previous classes. A table which shows the class intervals and the frequencies. In a continuous series, if you take a discrete series, continuous series and discrete series, having with frequencies. Because the frequencies starts with, there are two types of frequencies basically. One is discrete frequencies and continuous frequencies. Of course, univariate, bivariate also there. So the under this frequency table, continuous series, if you take class intervals, say for example 0 to 10, how many people got? Say for example 5 students got. 0 to 10 opposite to that 5 students. What does it mean? The frequency of 0 to 5 class are 5 students. 10 to 20 or 20 to 30 in a continuous series. Opposite to that, against to that class, how many students will come under that class? We have to specify. The number of students we have to specify. The number of students will be called as frequency, okay, related to that particular group. Next, let us move on to another slide. Basic concepts still continued. There are certain other points also there, in addition to the previous points. Class limits. What do you mean by class limit? The boundary limits of the class into which the data are classified. Class limits means what I mentioned in the previous slide and in previous class also. 0 to 10. Example, if you see the monitor, you can easily understand this. If you can see the slide here, you can have example. I am moving the cursor here, you just observe 0 to 10. So here the 0 is lower limit, what I told you in the previous few minutes back also, and 10 is the upper limit. And 10 to 20, if this is the class, 10 is the lower limit and 20 is the upper limit. And that is why 0 and 10 are the limits of a particular class or a particular group. That's about. Next, mid value or midpoint. What is mid value? Mid value is very easy. You can easily understand. A class you take, say for example, in the previous class, previous point, 0 to 10, 10 to 20, 20 to 30, like that I explained. Now you take to find out, to determine the mid value or midpoint, what you have to do is lower limit of the class plus upper limit of the class. If you add, then you will get some sum, SUM, some amount of the, both. Say for example, 10 to 20 is a class, 10 plus lower limit is 10, upper limit is 20, 10 plus 20, 30. So that 30 divided by 2. Why should we divide by 2? Because there are two limits. That is why we need to divide it by 2. So 10 plus 20, 30. 30 by 2, 50. So the midpoint of that class is 15. Like that, any class you can take and you cannot add the lower limit and upper limit and divide by 2, you will get the midpoint. Any classes you are supposed to calculate like that. So that's about the mid value or midpoint. And frequency distribution, also one of the point. It is a table in which the possible values of variable are grouped into classes and a number of observed values fall into that particular class. That's what I told you in the previous few minutes back. What I told you, 0 to 10 is the class, say for example. Under that class, pertaining to that class, how many students are there? How many students will come under that particular class? That you have to do. How to determine 0 to 5 are the marks or 0 to 10 are the marks, that group. In that group, the data will be given already for you. Out of that data, you have to identify. Data means, say for example, 40 students marks are given below. Like that, the problem will be given. So 40 students means all 40 students marks are given. That is the data. Now what you have to do, you have classified, you have prepared the classes by taking the lower minimum number in the data and taking the upper number of the data or maximum number of the data. On the basis of that, you need to create the classes. Classes not less than 5, the not less than 5 and not more than 15. It is convenient. Like that, you have to design the classes. So 5 or 15 in between you can decide. But how to decide that? On the basis of the data that you have given. If the data is large, say for example, if the data is large means 60, 70, 100 is given, say for example, 50, 60, 70 is given, then huge data. So when huge data is given, the class intervals, on the basis of huge data, the class intervals are to be decided. Whether you have to take 5 class interval, whether you have to take 10 class interval. Class interval means one class to one upper limit, the lower limit, the difference between the upper limit and the lower limit is the class interval. So like that, on the basis of that, you have to prepare the groups. The classes you have to prepare on the basis of the available data. On the basis of the available data that you need to uh, prepare the data, prepare the classes. You have to decide the classes like that. So that's about the frequency. Now, what is the point you have to understand? The frequency under each class or each group, you have to mention. Frequency in the sense how many students will come under that group. That you are supposed to mention against to that particular class, you have to mention. Say, for example, 10 students are there pertaining to 70 to 80 marks group. So between 70 to 80, there are 10 students. If you have identified in the given data, raw data is given to you. Some 50 students, say for example, out of 50 students, how many marks, how many students will come under that 70 to 80 category or group or class? So that you have to identify, you have to mention the number, how many students against to that particular group. That's about. Class means any two values in a frequency distribution. That's already I have explained. 0 to 10 is a class, 10 to 20 is a class, like that. Okay. Now let us move on to the next slide. What is the next one? What is the next one? Next one is that the cumulative frequency distribution. Cumulative frequency distribution. What does it mean? Cumulative distribution, one of the two limits will be employed if the upper limit is used. For example, if you use the upper limit, then it is preceded, the upper limit is preceded by less than, very important. The upper limit is to be preceded by uh, uh, the less than word. If, say for example, if lower limit is used preceded by more than, like that you have to use it. You can understand in a better way if you see the table here I have mentioned. Now see the table here. In this table, one example I have given you. What is that example? From the frequency distribution given below, obtain less than and more than cumulative frequencies. So the data is given under that. Marks are given, number of students. Marks are the data information grouped. It is grouped 30, 40, 40, 50, 50, 60, 60, 70, 70, 80, 80, 90. Like that it was grouped. And the number of students always will be considered as frequency. So under 30, 40 group, it is already grouped. 5 students belongs to that particular group, and 8 students belongs to 40, 50. 11 students 50, 60. 15 students 60, 70 marks group. 7 students 70, 80, and 80, 90, 4 students. They got marks. Like that, it was given the problem. Now, what you have to do is, according to the above, the less than and more than. For example, first class you take 30 to 40. 30 to 40 means if you take upper limit, if you take only upper limit, that is 40 if you take. Below that, less than, you have to talk about less than. 1 minute, be online. Less than you have to write. Less than 40, like that you have to write, because you have taken upper limit. Similarly, if you take other classes also, less than 50, less than 60, less than 70, less than 80, less than 90. Like that you have to prepare. And the marks are frequency distribution as mentioned 5, 8, 11, 15, 17, 4, like that. You have to, whatever frequency is given, opposite to that particular class, you have to write. That's about the frequency. But here, less than frequency distribution, a cumulative frequency is mentioned here. Cumulative frequency means how to talk about how to find out the cumulative frequency. You write the first frequency as it is and add the next frequency. That means 5 plus 8, 13. 13 will be the cumulative frequency of the second class. And third class, when you come to the 50, 60, then the cumulative frequency will become the above frequency, how much? 13 plus 11, right? Then how much you will get? 24. So 24 plus next frequency. How much? 24 plus next frequency, 15. It comes to 39. And 39 for next class, 39, and another frequency 7. If you add, then you will get, the 40, 46. After that, 4 you have to add, the last one. So then you will get 50. The cumulative frequency in a sentence, the first frequency should be added, the followed frequency, next frequency, subsequent frequency, and then above 2 frequencies should be added to the third frequency. So every frequency of that particular class should be added to the subsequent frequency, so that you will get the cumulative frequency. That's about. And the second table, if you see here, more than. We talk about up to less than, now more than. More than means lower limit if you take. What is the lower limit? 30, first class. So 30 more than 30 you have to write. Similarly, more than 40, more than 50, more than 60, more than 70, more than 80, like that you have to write. And under this, the frequency distribution in the previous table. So in this table, I am moving the cursor just to see. Here 50 is there. So that 50 you have to write here in the first, because more than 30 means all people will come. All students will come. That is why 50 you have to record here. And then what happens from the subsequent frequencies, 50 minus first frequency, deduct. 45 you will get. From 45, again you deduct for the next class 8, then you will get 37. From 37, again you deduct 15, then you will get 26. Like that, you go on deduct, then you will get the under this more than table, you will get the frequencies like this. Now, now you have the another important point that what you have to understand is that 1 minute. So in the next table, you can understand that the sometimes it is the next table related to the concept relative frequency. Under this, sometimes for the purpose of comparison, we need relative frequency. How do you find out the relative frequency? So here, as usual, the same above problem we have taken. Frequencies are recorded. Cumulative frequencies are recorded by adding these subsequent frequencies. Cumulative frequencies we have recorded. And relative frequency, how do you find out the relative frequency? Means frequency of that particular class divided by the total frequency. Frequency of the particular class divided by the total frequency. Say for example, first class is 50 frequency, and the total frequency is 50. 50 by 5 by 50 into 100. Then you will get the relative frequency. 5 by 50. 5 is the first class frequency divided by 50 into 100. So 15, 100, 2 times it will go. 2 into 5, 10. 10 is the frequency here. Similarly, you have to calculate all other frequencies, cumulative frequencies you have to calculate. Okay, you try for this. Next, you have some important questions. Already we are running out of time. Anytime it may be, the class may be winded up because the Zoom has given the warning. Now, important questions I give, because it is the last unit, last chapter of the unit, first unit. That is why I given you the important questions also. So here 10 questions are given, short notes questions, and the essay questions are also given. These are all very easy. You can easily do it on the basis of the previous classes explanation. You can easily do it. So these are the questions, and one more is there. This is also these two questions also. This is data. In this problem number 8 and problem number 9, data is given. So this data has to be classified into tables, and then you can you have to do accordingly and show it to me tomorrow, or otherwise if any doubt you have to if any doubt you have, you can ask me about the classification of table and the frequency distribution. If anything, if you feel doubt, you can ask me. I don't think you will not get any doubt, because all these things I have explained so far. Okay. Now this is about the last component of this first unit, last chapter. Okay. Now let us stop here, and tomorrow we'll proceed to unit 2, chapter 5. Okay. This is about